So, Professor Vijay Singh sir is a distinguished academician and researcher specializing in artificial neural network, blind source separation, independent component analysis, data mining, and digital signal processing. He holds a PhD from Dayal Educational Institute, Agra, where he contributed significantly to image audio separation, security applications, and text mining using novel ANN techniques. With over 3 years of research experience at IIT Kanpur, he has developed software solutions for Bhabha Atomic Research Center, Indian Space Research Organization, and Indian Oil Corporation. A member of IEEE and the International Association of Engineers, Professor Singh has supervised multiple theses and has an extensive publication record in very renowned international journals and conferences. He has also organized major events like IEEE international conferences and wireless communication and sensor network. So over to you, sir.
Thank you so much, sir. So I think all the participants are faculty members or students are also there?
No, mostly faculty members, sir.
Okay. So whenever you want to ask any questions, you are free to ask. Okay, and the today's title of the talk is Time Series Analysis and Applications. So because your FDP is on this yes, let me open it. So it is emerging issues and challenges in AI and communications. So that's why this topic is very much suitable for you, because all these things are actually the emerging trends. So I have used some of the images, some of the materials from some of the web resources where I have given proper citation to them. And rest of the material is my own. So coming to the data, because these days everywhere you can find out that data is there. All the companies are collecting data sets. And if you are having the data sets, you can actually get information. So data are the simply facts and figures, but when we add some context to the data, it becomes the information. The right hand side, if you see, there is a table. AB is the input, Y is the output. So if this is the data set, then we have machine learning algorithms known as supervised learning algorithms, which we can use in order to model this type of data set. Like 0, 0 is the input and 0 is the output, 0, 1 is the input, 1 is the output. So we can have some input neurons as well as output neurons, and then we can train our neural network, and then we can do further predictions if some new inputs are coming. Now suppose A, B, and Y all are data points. So all are inputs only, no output is there. So for this type of data set, what we can do some kind of clusterings where we can group these type of data sets. Okay, and these clustering algorithms are known as unsupervised learning algorithm. So they are supervised learning algorithm, unsupervised learning algorithm. So earlier we were having small data sets. Okay, because when this computer concept started, majorly for the payment related things. Okay, and the personal computers were there, basic Excel was there, and simply statistics people used to do, like mean, median, standard deviation, something like that. Then the concept of large data came. The order of large data was gigabyte to terabyte. Then computer were there as well as servers were also there. So client server architecture came. Machine learning algorithm came. Data mining came. So people used to write many algorithms that can run on a single computer system. Then advanced statistics, business intelligence, data mining, all these concepts were there. And then every one of us were started collecting the data set in form of a big data, that is the order of terabyte to petabyte to even more. So here we cannot store all the data set into a single system. So we have to store all the data set into distributed environment. And if we are storing any data set into distributed environment, and if your algorithm is running on a single system, that will not be able to take all the data set and make useful decision. So now what we have to do, we have to actually update our algorithm so that they can also work in the distributed environment. Then this concept of map reduce and other thing came. Okay, so millions of records are there. Unstructured data is also there. Structured data is there. Unstructured is there. Text is there. Audio, multimedia data is there. Okay, so all type of data set is available. So this is the era of big data. Coming to this last quadrant, where you see, you must have seen this type of signal. Okay, if you are going for your heart checkup, you can find out this type of signals coming. So what is happening here is, on the x-axis there is a time, on the y-axis there is an amplitude. Okay, and it is very difficult in this type of data set that what will happen in the future. So if you have certain information about this particular signal, you cannot exactly predict what will happen in the future. And this type of data set is known as time series data set, because we are collecting this data with respect to time. And we are interested in today's discussion about this type of data set, okay, which we are collecting with respect to time. So time series are observations on a quantity, random variables, collected sequentially with respect to time. Other examples are finance and economics, like Sensex index is there, price of Bitcoins. Most of people these days, they are interested in investing Bitcoins, cryptocurrencies, okay, or many other stocks. Geo is also launching their Geo coins. Environmental and natural science, like pressure, temperature, precipitation, rain, seismic signals. So actually, the scientists working in this particular domain, they are actually doing all these time series analysis in order to predict the weather condition. And the data set which they are collecting is all these, like temperature, precipitation, rain. Seismic signal they are analyzing. So seismic signal is actually earth-related data set, where they want to predict whether there will be earthquake or not. And in the case of seismic signal, 99.9% of the time, it is the noise, and only 0.1% of the time it is the signal, where they can actually use it and predict whether it is really an earthquake or not. Then engineering speech signals, like I'm speaking. So I'm collecting the data set with respect to time. Electrical power load forecasting, sequence of queries in a search engine, or frequency of query over time. Neuroscience examples, medical examples are brain activity measurement via EEG, fMRI, or other techniques. Spread of COVID-19 is again with respect to time. We can actually model this type of system where we can see whether this COVID is spreading or not from one person to another person. Genetics, microarray data for cancer detection. Security, event occurrences in a log over time. Internet web traffic, CPU uses, intrusion detection, vulnerability. Like suppose somebody else is using your system and you are monitoring your CPU usage, then what will you find that during some period, the CPU usage is much more as compared to the other time. Or maybe suppose in the night time, when you are sleeping and you have found that there is a CPU usage up to a certain extent, which you can analyze that if somebody else is, whether somebody else is using your system or not. Okay. So all this type of concept is known as cryptojacking. Okay. People are doing lots of research in this area. And there were many attacks when people are using your own system for mining the cryptocurrencies. So they are using your system. They are taking the processing power of your system. They are using the electricity being used for running your system. Okay. So in this way, they are actually utilizing your resources for their own purposes. So these are the examples of time series data set. Like you can see the SBI stock price left-hand side. With respect to time, some stock price is moving. Right-hand side is annual temperature data. then some sale of a particular shop, suppose. Okay. Then there is a internet web traffic data in bits from private internet service provider. Okay. So you can find out many more such examples where we can see that we can have one variable movement with respect to time. So this is the mathematical definition of time series, like let omega fp, that is the probability triplet, be a probability space, and t an index set. A real valued stochastic process is a real valued function xt omega, such that for each fixed t belong to capital T, xt omega is a random variable on omega fp. When the index set t corresponds to time indices, discrete or continuous, we'll call xt omega time series. For fixed t, xt omega is a random variable. For fixed omega, xt omega is a real valued function of t that is called a realization of time series. We typically suppress omega and write xt. So now onward, we will use this term xt for representing any time series data. So for discrete time series, the set of time t is a discrete set, whereas in the continuous time series, it is a continuous. So we have seen one variable movement with respect to time. We can also have multiple variable movement with respect to same time. Okay. And that is known as multivariate time series data. So you can see the example left hand side, there is a univariate time series data where there is a one variable we are modeling with respect to time. And in the case of second example, you can see with respect to same time, there are multiple things we are collecting together, and then we want to analyze all of them together. So a time series is a series of observation xit. We have introduced I here. It is called a univariate time series when I is equal to 1, and called multivariate time series when I is equal to or greater than 2. Multivariate time series analysis is used when one wants to model and explain the interactions and co-movement among a group of time series variables. So here we are making a combined decision by analyzing all the time series signals which we are collecting with respect to time, and then making decision. So modeling this time series is a difficult task. So modeling definitely this multivariate time series will be even more difficult task. So why working with time series is so difficult? So many of the process creates large amount of data in a small time frame. For example, 1 hour of ECG data is 1 gigabyte. So you are collecting simply ECG data, and it is 1 gigabyte if it is for 1 hour. Typical weblog, 5 gigabytes per week. Space Shuttle database, 200 gigabytes and growing. Macho database, that is astronomical database, that is 3 terabytes, updated with 3 gigabytes a day. Then you must have seen this Chandrayaan 2 and Chandrayaan 3 mission. So every time you are collecting lots of data set, because there are multiple sensors, they are giving continuous values, and then you are storing all of them. Okay. So you can see there are multiple examples where this time series, storing time series data will take huge amount of disk space. So that is the most difficult thing to work. Then there are data handling problems like different data formats, different sampling rates, noise, missing values, and so on. Here you can see there is a trajectory being followed, right hand side corner. Okay. So all these kind of trajectories after the launch of anything, any vehicle, we can actually predict from the ground level itself that what trajectory this particular object will take. So because all the data is sequential, all data items arrive in the data store in some order. In some cases, the order does not matter. We can assume a bag of word model for a document. In many cases, order is of interest, like a stock price, do not make sense without the time information. If we are having some time series data set, we can analyze it in time domain itself or frequency domain. So these are the standard procedures of analyzing time series data set, which you can directly plot and then do some kind of analysis. Or you can convert time series data into frequency domain data by applying some fast Fourier transformation kind of method. And then you can analyze the data set. So these are some of the major application areas of time series, like visualization. So that is the most important thing, and data visualization is a new course these days people are teaching. We also run this type of course. So if we are visualizing any data set, we can get many more information about the data set. Like right hand side, you can see there is a visualization of heartbeat. And then by seeing this, just doctor can tell whether you are having some kind of problem or not. We can do clustering, we can do classification, we can do pattern recognition, we can do forecasting. Forecasting like after the launch of a vehicle, what will be the trajectory, rule discovery, motive discovery, something is repeating itself after some time. Okay, like COVID wave 1 was came, then second wave was there. So all these things can be identified. We can also identify the period of recession, period of prosperity, and so on. Query by content, novelty detection, anomaly detection. Okay. So like suppose some multiple sensors are placed at some industrial location, and one of the sensor is giving that there is a fire going to be taken place, whereas other sensors are not predicting the same, or multiple sensors are predicting that there will be fire. So based on that, we can do some kind of clustering and we can find out some kind of anomaly also. So there are data pre-processing methods. So I'm just taking these names because they are not much relevant to this current talk. So data standardization, denoising, filling missing values, dimensionality reduction, volume reduction, feature extraction, and so on. Dimensionality reduction methods you already know, like principal component analysis is there, and then other methods are also there. Whereas volume reduction, like you are having a large amount of data set, and then if you are reducing that by applying suppose clustering algorithm, then you can get a small set of data set. Okay, or you will get a cluster. Then after getting the cluster, you can pick some of the data points for further analysis. So we can say that it is a volume reduction. Okay. So volume reduction can be obtained by clustering algorithm, whereas dimensionality reduction can be obtained by dimensionality reduction methods. So the representation and dimensionality reduction, the different representation of time series are classified into 3 categories. Temporal representation, keep a temporal point of view on the data, like with respect to time, whatever you are collecting, you are just analyzing it. A spectral representation, I have already said, you are converting it into frequency domain from the time domain, and then you are analyzing it. Then third one is the other representation, applies some other transformation that do not fit into the first 2 categories. And we are interested in this third line. That is the other kind of representation. And also for dimensionality reduction. We have said that there is a principal component analysis method. For dimensionality reduction, here we'll see some more method for dimensionality reduction of time series data. So one way is the symbolic representation. So we are representing a time series data in another form where we are also getting the dimensionality reduction. Like suppose the sinusoidal is a time series data set. Okay. So what we are doing for the symbolic representation, now suppose we want to represent this whole time series by using 3 symbols. Then what we are doing, we are creating a small block. Okay, suppose 10 items, 8 items, 20 items, whatever. Okay, so there are 8 blocks. And then every block, what we are computing the mean of the each block. And then what we have done, we have plotted this particular data set, or we have normalized this data set in the range of suppose -1 to +1, okay, or -2 to +2, or whatever range. And then what we have created 3 lines of boundaries. Here you can see that if the data is from -0.5 to +0.5, we are assigning this character B, 0.5 to 1.5 character C, -0.5, -1.5 to -0.5, we are using symbol A. So every block we are computing the average. Then we are seeing whether this average belongs to the first level, second level, third level. Whatever is the level, we are assigning that symbol. So now this whole time series signal can be represented using CB, CC, BAAB. Okay. So whatever is the mapping to the symbol, and in place of the whole data set, now we are using this just symbol. So this is known as symbolic aggregation representation method. So example of sex for a time series with parameter alpha is equal to 3 and w is equal to 8. The time series above is transformed to the string CBCCBAAB and the dimensionality reduced from 128 to 8 because every time we are taking 8 items, computing the average. Then people said that this taking the average is not intelligent decision because sometimes due to outlier they can create problems. Okay. Then people said that not only the average value, will also take the minimum and maximum value of each block. Okay. And that method is known as extended symbolic aggregate representation method. So now every block, like in this particular case, we are representing using a single symbol. If it is the extended version, then in that case, we'll also use symbol for minimum, symbol for maximum, as well as the mean value. So every block will be represented using 3 symbols. Okay. So now can you tell whether we are getting this dimensionality reduction or not? Yes, we are getting it because for storing the floating value or double value and for storing the symbol will take lesser amount of space, disk space in the storage device. Now suppose you are having this time series signal and now you have converted into symbolic form. Suppose there are 3 time series signals. 2 you are already having, one belonging to one class, second belonging to second class, and third is a new time series which is coming to you, and now you have to check whether the third signal is belonging to the first time series or second time series. What will you do? Whenever we have to find out the similarity, we always compute the distance. So in this case, when we are having these symbols, we can suppose find out Hamming distance. Okay. So like string A is there, A, B, C, D, E, F, G. String 2 is there, B, C, D, E, F, G, H. Okay. Then we'll check whether they are equal or not. Hamming distance can be computed in this manner. If it is not, then Hamming distance is 7. So if we are having signal 1, signal 2, and then there is a signal 3, new signal, what will you compute? You will compute Hamming distance between signal 1 and the new signal 2 and the new signal. If you are finding that the new signal is more closer to the signal 2, it means the distance will be lesser for the signal 2. And then what you can do, you can cluster that the new signal will be belonging to signal 2 category. So suppose, like in this particular example, what we have done, we have taken 3 symbols to represent. We can take multiple symbols for representing any time series. Okay. So not only 3, we can have multiple, like suppose we are having 10 symbols, we are having 20 symbols. Okay. The more number of symbols will get more resolution. So there is another example, like there is a class 1 signal, you can see here, time series signal. Class 2 signal is there. So what we are doing is, so this is another way of doing the same thing what we have taken the example by the Hamming distance. So this is another way of doing it. And you can see that right hand side there is a web link given to it where you can find out the algorithm which you can implement later on and then check. So there is a class 1 data set which you are converting in form of suppose A, C, C, B, B, C, D, A. Okay. So here we are using multiple signals. Like left hand side, you can see there is a time series data set, first time series, second time series, mth time series, and each time series data set we are representing using A, B, A, C, C, A, so all combinations. Okay. And then we are computing this term frequency and inverse document frequency, and we have created some kind of matrix. Some new signal come, then again we'll convert it in form of bag of word and then we'll match, and then we can get the probability like this new signal is belonging to class 1 or not. So time series, understanding time series modeling difficulty, why it is very difficult, what is the problem exactly behind the time series analysis is, left hand side you can see there is a temperature data set in the degree. Okay. So if temperature is more, you can see that there are more number of cells. Okay, maybe some cooler place. Okay, for a given value of x, there is a fixed value of y. Coming to the right hand side, this is the hysteresis curve. you must have seen in 10+2 class. For a given value fx, like suppose x is equal to 1500, then what will be the value of y? So what is the method? For x is equal to 1500, what we'll do, we'll plot a particular perpendicular line. That line is cutting this particular curve at two places. Hysteresis curve at lower place, hysteresis curve at the upper place. Okay. So what does it mean? For a given value of x, you are actually getting two values of y. So this is making time series a difficult problem, because in another cases, another examples, for a given value of x, you are always getting same value of y or a single value of y. But in this case, for a given value of x, we are getting multiple values of y. Okay. So now suppose we have to model this type of data. So how can we know that for a given value of x is equal to 1500, whether we'll get a lower value of y or upper value of y? So in this particular case, we'll require some more amount of data set in order to model this type of problem. And what is the more amount of data? Is nothing but the historical data. Like suppose if we are at the lower side of this curve, and then if somebody is asking for x is equal to 1500, what will be the value of y? So in that case, you can definitely say that it will be the lower value of y. If you are at the upper side of this curve, and then somebody is asking x is equal to 1500, what will be the value of y? Then you can immediately predict that it is the higher or upper value of y. So it means for modeling any time series data will require historical information. How to collect the historical information? Left hand side, you can see there is a time series data set. Suppose you are measuring temperature or any variable. Okay, so what will happen? As time is equal to 0 or time is equal to t is equal to 1, 1.87, t is equal to suppose 5 minute, 3.1, t is equal to 10 minute, 0.99, 3 is equal to 15 minute, 3.92 and so on. So time series will only return you a single value. Okay, so you can see the middle matrix. Here what we have done, we have just copied the cell 1.87, 3.1 and so on. Next cell, what we are doing? We are copying and pasting the same cell but one row above. Third line, one row above. Fourth line, one row above. And then what we are doing, we are taking this colored part only by discarding the upper and lower triangle. Okay. And now what we are saying, we are saying that t is equal to 1, t is equal to 5 and t is equal to 10 is the input, t is equal to 15 is the output. T is equal to 5, 10, 15 is the input, 20 is the output. So now what we have done, we have actually created the historical data set from the given time series data set. And what we are saying that there are now 3 inputs and 1 output. Okay. We can have 2 input and 2 output also. We can have 3 input and 5 output also. So whatever is the problem, whatever is the requirement, we can actually model it. Okay, so now you can see that first day data, second day data, third day data, fourth day is the output. Then second, third, fourth is input, fifth is output. Third, fourth, fifth is the input, sixth is the output. Okay. So now if you are having this type of data set, we can say that now you have embedded this historical information into this data set. So that is the trick for making the time series data into a historical form. In this particular example, what we have done, we have taken a time delay of 1 unit. We can take time delay of suppose 7 days. Okay. Like a stock market, if we are analyzing, so Monday. Okay. So what we'll do, we'll take the data set in the interval of 7 days. Okay. So for a Monday data, this Monday will get the previous Monday, before that previous Monday and so on. Okay. So this we can define by our own. So what do we want to do with the time series data? We want to do clustering, classification. We have already said motive discovery, rule discovery, query by content. You are giving a small query and then based on that, you are searching for the content, visualization, novelty detection, anomaly detection. Okay. So this is database management system models and popularity. If you'll search, there is up to 2024. If you'll find out 2025 also, okay, there is a link given here, dbengines.com ranking of categories. Okay. So what you'll observe, even 2025 data, January data is available there. Okay. If you'll see, what you'll find out that this graph database management system has gained much of the popularity. And then the second important thing is this time series database management system. Okay. So emerging issues, emerging trend is the graph database management system. That is the top level. Then second top level is the time series database management system. Okay. Why this graph database management system is getting more popularity? Because of use in the social network analysis. Okay. So all these concepts are there. These days, people are more interested in social networks and other things. Okay. That's why this graph DBMS. Then the same concept is being used in the generative AI models, like ChatGPT is there. Okay. DeepSeek AI is there. So all they are using this connected networks, graph networks, in order to establish relationship among the variables, parameters, databases, okay, and then generating the results. So we are interested in this time series database management system. If you see, you will also find out the ranking of different time series database management systems. Okay, like InfluxDB is there, so it is a time series multi-model. So different time series database management system exist, and then they support different kind of features. Okay. Okay, so I'm skipping some of these slides. Okay. So why this database management, time series database management system is gaining much of the popularity? Because it is everything comes from the industry. Industries are interested in this particular database management system, and that's why it is gaining the popularity. Because industries are analyzing the human requirements. Based on that, they are developing, creating new products. And that product, because everyone is interested in whatever they want to do, so they are purchasing those products. And that's why this time series database management system is gaining popularity. So what are different examples of time series database management system or time series data sets? This is first example of agriculture, where you can see there is a farming land, and that farming land you want to monitor. Okay. So not only this, suppose if there is a mango tree, you are having a small forest of mango tree, then you want to monitor this whole mango tree forest. Then what will you do? You can use drone. Drone will definitely have cameras. If we are capturing any image, video, it is with respect to time. Or time to time, you will analyze, you will monitor your farming land or your trees. You want to find out whether there is some attack of insects or not, whether some pesticide requirement is there, okay, whether some diseases are there on the leaves. Okay, so all these kind of analysis you want to do with respect to time. So what will you do? You will monitor it with respect to time. So this can be considered as the time series data set. Okay. There are automatic irrigation systems coming these days. So you want to monitor the water level on the farming land, okay, by using different sensors. And then whenever there is a requirement, it will automatically trigger, and then automatic watering will be there. Okay. You can see there is a term mentioned here, that is IoT in agriculture, that is Internet of Things. Okay. And this is very much attractive term these days. People are using this IoT, machine learning, deep learning. Okay. All these are very much being used by different people. So what is Internet of Things? Everything we want to connect using intelligent systems. So like here also, and what is this Internet of Things? Is everything you want to monitor in real time. Anything if you want to monitor in the real time, definitely it will be the time series data. And that's why this topic is very important. So like crop yield analysis, auto spreading, people are using drone cameras for spread of this pesticides also, diagnosis of diseases, variable rate of fertility, water stress, okay, soil erosion, field monitoring, many more things can be done using your computer system. But the key idea behind all this thing is you want to continuously monitor the overall land for a particular purpose. Right hand side, you can see there are human-like structures. Earlier or nowadays also people are using it. And whenever some insects, some bird, animals are coming, they are seeing and they are assuming that some humans are there, they will not come to this farming land. So we can replace this type of system by using some intelligence system where we can have some drums, we can have some cameras, we can have some intelligence system that can actually identify some animals are coming, some nilgais are coming or not, and then they can play a huge sound on the drums. Okay, and then they will run away. So they are actually making lots of loss to the farmers, and that's why these kind of devices can be useful. Coming to the smart home, every one of us these days, we are having Alexa, Google Assistant, and all these kind of smart things. Even our televisions are smart, our air conditioners are smart. They can all automatically detect whether some humans are there in the room or not, and in which direction humans are there, so they can adjust most of the things. So this is the era of this smart home, smart devices, smart bulbs are there, where we can voice based, you can control the smart bulbs. Okay, like after the mosquito net, you will not want to come out for switching off the light or for dimming the light. You can just give the command by using your own voice, and then everything can be controlled. So we can have the security and surveillance cameras. We can have cameras because some small kids are there at the home. You want to monitor them remotely because you will be at your work, but you can find out some solution to take care of your kids. So cameras are already coming with the pre-installed software that can analyze whether the child is crying or not. Okay. So it's a kind of continuous monitoring. Or some humans are coming in the range of that camera. Okay. So human detection. So all these basic features are already there. Smart lighting, temperature control, health and wellness. Okay. So all these kind of thing can be done. And everywhere you can find out there is a time series data set. This is the example of healthcare where person or elderly people is wearing a wearable system. Okay, and that system, that wearable like shirt is there. Okay, and that shirt is actually having multiple sensors. One sensor for suppose oxygen level meter, second sensor is for temperature, third one is for blood pressure, and so on. Okay, so this is very nice example of multivariate time series system. So here multiple time series data set we are collecting together, and then based on that we are making decision whether the person is going to get some heart attack or not. Okay, and if this is the probability, this device will actually connect to the system and then will inform to the physician, will inform to the ambulance, will inform to the patient relatives. Okay, so that all the arrangements can be done, and then electronic health record will automatically be shared with the physician. Okay, so all these type of systems people are developing in European places. Okay, in India some people are also working here also. So this is a very nice example of multivariate time series data set, because here we have to collectively make decision based on multiple time series data set, because only one parameter will not be sufficient to predict anything about the health of the person. Okay. This is the example of Tesla car. So you can see that there is no driver here. So car will automatically drive from the source to the destination. So definitely it will have multiple type of sensors connected with it, and continuously it has to monitor all of them together, and then it has to make decision whether to brake or not. Okay, whether to take a turn or not. So this is again the example of multivariate time series system. This is another example of cow on IoT platform. Okay, so there is a one nice video, Connected Cows by Joseph Siro of Microsoft. So Microsoft along with the Fujitsu, they have developed this integrated solution. So Fujitsu has come up with the stress detection system for cattle, that is wearable for cattle. Okay, especially for cows, but it can be used for other animals also. And then Microsoft has actually developed the integrated solutions where in the cloud you can get the status of this particular cow. So what is happening? This particular device is a kind of pedometer, like we are wearing the watches for monitoring our footstep every day, how much we are walking. Okay, so it's a kind of similar device. You can see on the leg of a cow, we can just put it, and it is stress detection system for cattle. So stress detection means it is the period when the cow comes into the heating state, and then the farmer has to bring this particular cow for the artificial insemination so that she can produce children. Okay, so what is happening? What is happening? It is continuously monitoring the number of footsteps for the cow. Okay, and during the stress period, when the cow is coming in the heating state, it is making more number of steps, and many of the time it has been found that cow run away from the place, and then even farmer is not knowing whether the cow is in the heating state or not, and majority of the time it happens during the night time. Okay, so what is happening? They have connected it with the wireless system. So whenever they are detecting that cow is in the heating state, it will automatically send information to the system. That system will automatically send information to the farmer, and then farmer will immediately go and bring this particular cow for the artificial insemination. So what is happening? That what they have observed, that this particular period is actually for 16 hours. And if they are going for this first 8 hours for artificial insemination, it is producing a male child. And second 8 hours, it is producing, sorry, first 8 hours, it is producing probable female child. And second 8 hours, it is producing probable male child. So what is happening? Because of this device, they have actually controlled the number of cows or bulls. Okay. And not only this, they have also detected around 6 to 7 type of diseases in the cows. Okay. So because of this small device, because of the footsteps, how cow is taking, you can see here the plots. Okay. There is a standard plot of this blue color. There is a plot where there is a high frequency coming. Okay. So both are the time series data set where we can actually identify when we have to bring this cow for the artificial insemination. And then they have converted this whole idea into lots of money, and they have even produced more milk production as well as the cow production. So whatever they want, they can just tune it so that they can generate the female child or the male child. So this is another example of AI toothbrush. So what you can observe, that this is smart brush. Okay, it is not like I am promoting Oral-B. This video was available, so I have taken. So what is happening? How properly you are brushing your teeth, it can be detected using this particular intelligent brush. Okay, where you are putting more pressure, where you have not properly brushed. So you can connect it with your mobile system. You can change its colors. Okay, so all this look and feel, definitely industries are interested. Like whatever you want, they want to give it to you. Okay, and then this is again a time series data set which you can analyze and you can use this system. This is the industrial applications. So like this is ONGC gas pipeline explosion in Gujarat. So this you can actually monitor with respect to this time series type of data set. Like multiple sensors are there. And then if you are recording, you are analyzing the data set in the real time, you can actually predict some explosion will be taking place or not. Okay, so that you can alert the people working in that particular area. Okay, so that will be useful. Many places, if people are not utilizing it, we are facing certain kind of problems. Like in the Mahakumbh these days, you must have heard yesterday's event that multiple people were actually died because of some mishappening, and that is because the proper monitoring was not there. Okay, so like crowd are coming, so they have to immediately predict and they have to stop the crowd at the earlier level, not after reaching to the particular place. So that's why if you are analyzing everything in the real time, that will be useful. Otherwise, there is no use of time series. This is another example. Like you can see that there is a different kind of leaves. Okay, and all these leaves can be converted in form of a time series. There is a web link given below where you can get the code. Like you must have find out that there is a sweet neem leaf and the normal neem leaf. So one is sour and one is sweet. Sweet leaf, neem leaf we use in the cooking food, whereas other is having the medicinal purposes. Okay, but if you see the leaf, both the cases, you will find out they are very much similar. Okay, but if you want to solve this problem as a time series problem, we can convert any kind of leaf in form of a time series signal shown in the right hand side plots by using the codes given below. So it means if some problem is there in the image processing, if you cannot solve them in the image processing domain, you can bring it into the time series domain. So this is just showing you the strength of time series analysis, that not only the time series signal, but other type of data set can also be modeled using time series by converting them into appropriate form of time series. This is one example. We did one project for TVS Motor Company in 2007. So you can see that there is a test rig here. Okay, what is test rig? This is the test rig. So test rig is a test rig installed at the assembly line at the TVS Motor Company, Hosur. And here, what is happening? There are multiple this engine coming while manufacturing a bike. So what operators were doing earlier, they were actually putting this engine onto this test rig, connecting all the wires, fuel and everything. They were starting this engine. They were listening the sound of this engine. And then based on the listening the sound of this engine, they were predicting whether it is good engine or not good engine. Okay. So what was happening earlier, the engines were having some fault, and then this system was going to the customer, and then after claim by the customer, they have to invest lots of money in order to investigate it. They have to bring back the overall motorcycle at their research place, and then they have to analyze. And when there is a engineer coming from Singapore, he was charging huge amount of money for just investigating the issues. So what they wanted from us was that whether we can convert this whole system into the intelligence system, which can analyze whether the engine is good or not good. Okay, because earlier humans were doing, so humans can have some kind of, suppose boredom, suppose they have a fight at their home. So if they are very much tired, so many more things are there. If they are continuously listening to the sound of the engine, okay, so all these problems can lead to the wrong decision. Okay, but if we can convert the whole idea into some intelligence system, that will be useful. So what is happening earlier, the operator was listening. So what we have done, we have actually used 4 microphones, piezoelectric microphones we have used in order to capture the sound of this engine. And then we have used some data acquisition system, converted the time domain signal or the analog signal to the digital signal. And then we have written our own machine learning algorithm in order to analyze whether a particular engine is good or not good. Okay. So it is a time series signal because we are starting the engine, recording the sound of the engine. So with respect to time, we are recording the engine sound, but from different directions, 4 direction in this case. Okay, then we have converted this whole system was converted finally into the touch screen based system here, installed along with this this test rig as well as the printer. So immediately when the operator was starting this engine, it was predicting whether this engine is good or not good. and some sticker printing was there. You can put it on the engine. If it is not good, it will go back to the respective place. So not only this, that engine is good or not good, we have predicted around 6 type of faults. Like the fault is related to cam chain, fault is related to primary gear, fault is related to magnetorotor, cam chain, then primary gear whining or tappet noise. Okay. We have also told them that some engines are good and some engines are really very good. So this they were even not knowing. Then they told that yes, some of the users are reporting that whatever mileage they are mentioning, they are getting even more mileage, whatever company is mentioning. So this is because of casting of the engine or the material, even they were not knowing. So engines were actually having, some of the engines were really very good. Not only good, but very good. Okay. Which was giving them more accuracy. So classifying the engine into the good engine or not good engine, or what are the possible type of faults, this we have predicted, and the system was successfully installed at TVS Motor Company, Hasur. So you can see that this is the TIFAC website, Government of India website. They have mentioned the system was installed at assembly line and is working satisfactorily. TVS Motors has acknowledged this as one of the best projects ever implemented by them. Okay. So this is the example of time series. This is another example of time series. We did one project in 2012 to 2015 for Panna National Park. So here you can see that there is a forest in Panna National Park is there. You must have heard in the Madhya Pradesh. And what was happening there, there are lots of poachers used to get inside the forest, used to kill the animals. So there was gunshot. Our objective was to detect the gunshot and to localize the gunshot to protect the animals, wildlife of the forest. So what we did, we have used electronic modes that can continuously hear the sound, any sound in the forest. And then there are sounds, then we have to detect whether it is a gunshot or not. Okay, so it is again a kind of time series signal analysis. Then we have developed one virtual fence. You can see here source to destination, there is a red line. So this I will show you from some picture. So if some people are crossing this boundary, it will immediately tell whether humans are coming inside the forest. Or suppose some animal is crossing this boundary from the forest going to the villages, then it will also detect whether it is animal or not. If it is animal, then whether it is elephant or tiger, leopard or any other. So this was the collaborative project where NSF has also funded USA. Okay, so firing gun and then localizing it where exactly it has happened. So rifle in the open ground, you can see rifle near the water flow. It is having different structure, different spectrum. Okay. So you can see different pictures. So this was the elephant we used to go inside the forest using this. And this is myself putting the sensor on the tree. And these are our students also along with me. And this was the person who was taking care of the elephant. These are the some forest guard, because we have to collect lots of data inside the forest, firing the gun and then collecting it. These are our some of the students analyzing the signals. Okay, these are the stick which we are using for just communicating, checking whether there is a long range communication possible between the electronic modes or not. Ohio State University startup is there, Samraksh. So they have actually produced this type of mode, and what we have tested that around 2 kilometer length we can communicate using electronic modes. But if there are lantennas in between, small shrubs, herbs, then it will be difficult to communicate. So that's why we have taken around 200 into 200 meter grid for putting the sensors. Okay, and this is the example of fiber optic cable which we have to put below the earth around 1 to 2 feet, and then if some animal is crossing, then we can immediately detect whether it is elephant or not, or tiger or leopard. Okay, so this data set we have also collected from Chhatbir Zoo of Chandigarh. Okay, our student went there, and then in the zoo, these are the zoo person, they have also helped us. You can see different type of data set which we are getting. Like for tiger, we are getting this type of pattern. Humans, we are getting this type of pattern. Elephant, we are getting this type of pattern. So we can actually differentiate between different animals. So this is the example of time series data set. So what is similarity? Similarity is something which is very difficult to say. Okay. But when we see it, we know it. Okay. If we are seeing that both are looking similar, we can say that they are similar. Okay. But we cannot actually tell whether both are exactly similar or not. Okay. The quality or state of being similar, like likeness, resemblance, as a similarity of features. Okay. Similarity is hard to define, but we know it when we see it. The real meaning of similarity is a philosophical question. So I have already said that if you want to find out similarity, we have to find out the distance. If distance is less, similarity is more. If distance is more, similarity is less. That is the basic definition. You can achieve it by different ways. So similarity at the shape level, similarity at the structure level. So sometimes when we are saying that both shapes are same, we can say that it is same. If they are not same by the structure level, then we say that it is not same. But when we go inside analysis of the data set, we find that they are same. You can see this example. There is a data set X, there is a data set Y. Okay. You can see there is a data set A, there is a data set B, and left hand side is a plot. After seeing this, can you say whether they are same or not? So after seeing this, you will say that left hand side data set, they are not same. Okay. But if suppose if we are normalizing this using Z normalization method, both the data set, and then we are plotting the same data set which is at the left side, you can find out that both are exactly same data set. Okay. So it means sometimes what happens if you see it, they are not looking like similar, but actually they are similar. So it means we will require some more algorithm which can actually predict whether a time series is similar or not, same or not. Correlation, all of you must be knowing, but there is a term known as spurious correlation. Mathematically, you are computing correlation between two variables. You are getting very high correlation, like birth rate of monkeys and birth rate of donkeys, and you are getting correlation 0.95. Then what does it mean? If the birth rate will increase for monkeys, definitely it will increase for the donkeys as well. But biologically or practically, they are not at all related. So what does it mean? Mathematically, you are getting some good values, but actually in the practical level, there is no meaning at all. So this type of correlation is known as spurious correlation. Okay, you can see this is a long 1926 paper. Why do we sometimes get nonsense correlation between time series? I study in sampling and the nature of time series. Okay. So these are some old analysis. Okay. So now come back to the original table where we have created the data set from a single variable time series. Okay. So, and we have given the name input 1, input 2, input 3, and fourth one is the output. So 1, 2, 3, fourth is the output, 2, 3, 4, fifth is the output, 3, 4, 5, 6 is the output. Okay. And now if we are having this type of data set, we can apply regression algorithm also. We can apply neural network algorithm also. So for applying the neural network for this type of data set, we can have 3 input neurons in the input layer, 1 output neuron at the output layer. Then in between, we can have multiple layers with multiple neurons. And then we can train it. We can use the same system for prediction purpose. Then the concept of deep learning came because earlier what we were doing, we were analyzing the data set. We were doing pre-processing lots of time, around 60% time we were putting effort for pre-processing the data set. Then around 20-30% for classification or prediction, 10-20% for reporting. Okay. So we were investing lots of time for pre-processing the data in order to get the useful features. But here in the case of deep learning, what we are doing, we are at the same time, we are extracting the features and then we are doing the learning as well. So extract the feature, do the learning, extract some more feature, do the learning, and so on. Continuously, you can model the whole system. So you can see there are lots of deep learning applications. Deep learning, there is a convolution neural network, and convolution is having a special property. Suppose there is a original image of 6x6 size. This is the image example which we can work with the time series also. We define filters, and then we convolve this filter with this overall images, and then we generate the output. Like you can see, there are different kind of filters. Like the first filter is there, -111, -111. Horizontal is 2. Then vertical filter, you can see vertical line is 2, rest -1. Diagonal 45 degree is 2, rest is -1. 135 is 2, rest is -1. So what does it mean? You can see that there is a home picture. If we are applying this horizontal filter, horizontal lines, it will produce all the horizontal lines exist in the image. What does it mean in the case of deep neural network or convolutional neural network? We apply different kind of filters that actually extract data into different angles. Okay, like if we are applying this horizontal lines, we'll get horizontal lines. We'll apply this vertical filter, we'll get vertical lines. Okay, so all multiple filters we use so that we can see same data set from multiple angles, and that can be considered as the features. If we model them, they are producing very good results. Okay, all these things you must be knowing the deep learning concept. So we have also given one convolutional neural network architecture for time series analysis. There is a paper. Anjali Gautam is my student. She is now assistant professor at IIIT Gwalior. So she has worked on this time series analysis data set. And this was the paper, CNN VSR, a deep learning architecture with validation-based stopping rule for time series classification, applied artificial intelligence. So here you can see we are having convolution layer, max pooling layer, dropout layer. So time series data we have converted into special form. And then that form we are giving it to the feature extraction module as well as classification module. And then what we applied, we have given all these kind of data set. This is the benchmark data set available on the Kaggle. So beef, CBF, coffee. So some of these data set are multiple class data set. Okay. Training size, testing size is also given. Some are simulated data sets, some are sensor data sets, some are motion data sets. So you can see there, this is very good benchmark data set. UCR repository. This is not from Kaggle, UCR repository. And then we have compared our algorithm with the best algorithm. You can see the second column. So up to that time, the name of the best algorithm was also there. And we have compared our algorithm with the best algorithm, and what we have found that in the majority of the cases, we are getting better results. Okay. And then what we did, we have updated our model by using some biological based neuron architecture. That is the spiking neural networks. You can see that another paper, that is CLR based deep convolutional spiking neural network with validation based stopping for time series classification artificial intelligence. So here we have added one spike encoding part. You can see there is another block in between. So here we have used a spiking neural network model. And then what we got, and then you can see that there are multiple filters we have used, convolution filters. And then what we got almost in all the data set best result as compared to the best algorithm, except this faces all and faces UCR data. Okay, so except these two data set, in all the cases, majority of the cases, we got 100% accuracy. Okay, by updating this. So this is the strength of convolution neural network or deep neural network. Okay, and the idea behind this is this multiple filters. We are using multiple filters. If we are using multiple filters, definitely dimension will be increased. And then this deep learning tells us that we should reduce the dimension in the some another layer, and then we can do the learning. Okay, so you can see different type of kernels will produce different kind of results. And if we have compared, when we have compared, we got very good results. We have also applied the same algorithms for multivariate time series data set. And then we have also found many of the times our algorithm has given best result as compared to other model. So these days, this generative AI concept is there. So I will take only 5 more minutes for giving the latest state of the art in the time series forecasting. So all these we did, I think 2, 3, 4 years back. And now the era of time GPT has come. You must have heard chat GPT, but there is another GPT transformer model that is known as time GPT. Okay. So you know the strength of transformers. So this is the generative AI model for time series forecasting. Okay, so if you want to use this time GPT, you can directly go to the Nextla is the website where you can get this time series time GPT model. Okay, transfer model, which you can directly use. You can see here that time GPT, you have to just call this token, this time GPT transformer model. Then you have to give your own data set, like historic DF, you have given your data set, forecast DF, what you want for forecasting for this data set, and then plot. You can see that by writing just 1, 2, 3, 4 lines, you'll get the prediction along with the plotting. Okay, you can, if you want to find out anomaly, you can immediately detect the anomaly. All these models are there. I'm not running it. Okay, you can see the videos. I will share my slide. Okay, so this time GPT is the latest state of the art, and I've already said only by writing 4 lines of code, you can solve any time series problem, any forecasting. And what you can observe that this forecasting is even best as compared to any other existing. So what is behind the strength of this time GPT model is because there are huge amount of data set, time series data set worldwide available, and they have trained their model on all the data set. So it is not only predicting the values for your given time series, but it is also finding out the relationship between your time series with the any other hidden or directly indirectly connected other type of time series data. Okay, some war is there, so definitely there will be effect on the market, stock market. Okay, so you are predicting for a stock market, so it will automatically link your data for prediction purpose. It will automatically collect the war data set, what is the status of war. Okay, so not only for the your given data set, it will collect other type of time series data for making decision, for predicting for your time series. Okay, so I think you can see this video later on, and you can use it for prediction purposes. So these are the important concerns, like feature extraction is a concern, lots of dimensionality leading to the big data, fusion integration complexity because you have to integrate data set, real-time decision making, control forecasting, modeling in distributed environment and prediction real time is the need of the hour. Security and privacy is definitely is the major concern. So this is the summary of the talk. Time series signals are everywhere. To all classical approaches, there are machine learning alternatives. Deep learning offers tremendous opportunities for modeling the time series data, but problems are much vaster than prediction and classification. Modeling in distributed environment and prediction in real time is the need of the hour. So that is the key which you can take. So there are important points from this whole presentation is like time GPT. You must learn how to use it because it is available. Lots of uh, web content is there, and you have to just write 4 lines of command. Okay. So thank you. This is my deep learning laboratory, which I established at IIIT Allahabad. We work in time series, pattern recognition, information security, cyber security, medical application. Some of my students are working on the hate speech detection. Some of my students are working on this autism detection, and now we are developing some solution for autistic students, autistic children's. Okay, some of my students are working on the deepfake images and so on. So I am the only one, but I am one. I cannot do everything, but I can do something, and I will not let what I can not do interfere with what I can do. Edward Everett Hale. Okay. So with this line, I am stopping at this moment. If you want to ask any question, you can ask.
Thank you, sir. Thank you for such an insightful lecture.